Next thing we're going to look at are some simple trig equations. And like everything else we've done with trig, this is going to come back to kind of being able to visualize the unit circle. We'll start with some ones involving sines and cosines. We'll move on to other trig functions. And in the next video, we'll see how we can use some algebra to make them just a tiny bit more involved. But it's all going to kind of come back to what we're doing with sines and cosines. Now, for a first example, we're going to solve the sine of theta equals 1/2, which means I'm asking you what angles have a sine of 1/2. Unless I tell you otherwise, we are always going to solve our trig equations over the interval from 0 to 2 pi, basically one time around our regular unit circle. If I didn't say that, how many angles have a sine of 1/2? Really, there are infinitely many. We don't really want to deal with those. Okay, find a sine of 1/2. Well, if we're thinking about the unit circle, the sine is our y-coordinate. I want to know what angles have a y-coordinate of 1/2. Well, since it's 1/2, I know it has to be going up, so it's going to be in quadrants 1 and 2, and 1/2 is the smallest amount I can go up. I think this angle will have a sine of 1/2, and I think this angle will have a sine of 1/2. What are those angles? Pi over 6 and 5 pi over 6. Done. This is why I've been making such a big deal of being able to visualize this unit circle. If you can visualize it, you can jump straight to these answers. Next one. Let's solve the equation, the cosine of theta equals negative root 3 over 2. Cosine of theta equals negative root 3 over 2. Remember that around our unit circle, the cosine is the x-coordinate. I want to know what angles have an x-coordinate of negative root 3 over 2. Well, since it's negative, I know I'm looking over here, quadrants 2 and 3. Negative root 3 over 2 is the biggest amount that we can move. That's not 1, so I think I'm looking at this angle and this angle over here, these two. What are those angles? 5 pi over 6 and 7 pi over 6. It gets a little more involved with our other trig functions. However, as long as we can turn our ideas into sines and cosines, that's all we need to do. So let's take a look at the cotangent of theta, which equals root 3. I don't like cotangents. I'd rather deal with cosines and sines. So how about I say the cosine of theta over the sine of theta equals root 3, or how about root 3 over 1? Which is like me asking you, where's the cosine root 3 and the sine 1? And that's not an option. I don't have those values around my unit circle. But look at this fancy thing I can do. I can divide my numerator and my denominator by 2 without changing the problem. So now I'm looking for a place where the cosine is root 3 over 2 and the sine is 1/2. Okay, the cosine is root 3 over 2, the sine is 1/2, both of them are positive. I'm talking about quadrant 1, this angle over here. The cosine is root 3 over 2, and the sine is 1/2. My answer is pi over 6. However, there is going to be a second answer. I said this was root 3 over 2 over 1/2. Couldn't I also say this is like negative root 3 over 2 over negative 1/2? Wouldn't that also simplify to root 3? Now my question becomes, where is the cosine negative root 3 over 2 and the sine negative 1/2? I think that's over here. My cosine's negative root 3 over 2. My sine is negative 1/2. That angle is 7 pi over 6. One more. Cosecant of theta equals negative root 2. I don't want to do this. I'd rather deal with the sine. Sine of theta equals 1 over negative root 2, which isn't one of my good values, but if I rationalize the denominator, it will make things a little better. Let's multiply by root 2 over 2. That gives us the equation sine theta equals negative root 2 over 2. That is something that I can find around the unit circle. I now want to look for places where my sine, where my y-coordinate is negative root 2 over 2. Where is my y-coordinate negative root 2 over 2? Halfway in the middle and in quadrants 3 or 4. I think I'm talking about this one, and I'm talking about this one. What are those angles? 5 pi over 4, and 7 pi over 4. 5 pi over 4, and 7 pi over 4. Like everything else, it all comes back to being able to visualize this unit circle. I would spend some time playing around with that delta math stuff to just get a little more drill and kill practice with these things. This in particular has got to be solid. We're going to be using these trig equations all year.